Today is day 6 of Unit 4. We're going to be talking about geometric sequences, but before we do that, I just wanted to go over your homework questions from the last lesson. So if you could go to page 15, number 4 was the first one you had to do. So I just wanted to show you or point out how I would have liked you to write out this equation based on how the question was asked. Okay, so another way that we could think of our original equation, which is y equals a times the quantity 1 plus r raised to the x power, or of course 1 minus r, is we could put the word balance in. Balance refers to, like at a bank, your balance is how much money you have. Principal is how much you started with. Okay, so basically what they did was our a value, same exact thing, except I just put a p in there. So just kind of showing you a couple different vocabulary words, what you would be looking for. Again, initial amount, principal, same exact thing. Okay. And then you have your percent. You always want to change that to a decimal before you make that your r value. And then t is just the substitute for the x. Okay, so again, all we're doing really is we are substituting the variables that they give us. I want you to get in the habit of doing that, because if they do ask you that, if I ask you that on a test or in a regent, that just shows me that you actually read through everything and you see, okay, well, it says to find b. So obviously I have to have a b in my answer. And then it says after t years, so I better have the variable t in there as well. And then of course for b, so I do know that the b value is greater than 1, so it has to be growth. Also, remember, interest always refers to growth. Okay, and then we have number 7. So I told you for number 7, that one you guys just had to figure out if it was a growth or decay, and then it gave you specific years and it wanted you to find how much more. So we did a question like that in the previous lesson, and you find the answer to both of those and then you just subtract. So for that one, the answer was 46,656. And the last question you had to do, they just wanted to know basically what the r value is. Please make sure you guys know what the word depreciation means. It was on your quiz, so obviously that is a word that we use occasionally or most often. Depreciate, think of like a depression. That is a negative word. Negative means down. However, you have to remember, but depreciation, if you buy a car, usually that's what they're talking about. As soon as you drive a new car off the lot, it depreciates. The older a car is, the less it's worth, right? If you were to buy a brand new computer and then use it, are you going to be able to sell it for the same exact price that you bought it at? Probably not. The value of it is going to depreciate. So all that means is that it goes down. So think about what you're reading before you try this out. Okay, and then I told you in the last lesson, so this right here in the parentheses, we want to know our r value. So we always know that it isn't it's with respect to the number 1. So since this is 0.37, we know that it's a decay, so we do 1 minus r. So all I did was I set it equal to 0.37, and then I solved for r. So I got 0.63. Now notice that is an answer right there, okay? Also, they are thinking that you might not know the equation, so you might just say, oh, well, this is the percentage, so obviously A is the answer. Don't be fooled. Remember, it's always with respect to 1. So if it's less than, you're going to have to subtract that from 1. If it is more than, same thing. So you can see how much more it is. Okay? Okay. So you should be on page 17. Today we're going to talk about what is a geometric sequence. Okay, so a geometric sequence is a number sentence formed by multiplying a term in the sequence by a fixed number to the next term. We call this the common ratio, and we use the variable r. If you think about this, it makes sense, okay? So we called when we were looking at tables in our exponential functions, that's what we were looking for, is we were looking to multiply to get to the next number. So if we have the common ratio, that's what we would do. So the purpose of this of today's lesson, and bear with me on it, I know it's going to be a little bit difficult, but we are going to, if given a set of numbers, we are going to be able to write an equation from this, to write a formula, okay? So in the calculator, you would divide each term by the previous term. So if you look at example A, what you would do, now in your head, you might be able to do, in your head, you might be able, love the computer, never cooperates. Okay, so in your head, you might be able to look at these and say, okay, to get from 20, to get to 200, I know I have to multiply by 10. Okay, so each time I'm multiplying by 10 to get to the next one. Okay, so what I would be doing, so I'd go here, okay, and then here, okay, and so on. Each time, I'm multiplying by 10, right, each time, and so on. So, this is a geometric sequence, so I would say yes, and r equals 10. Okay? Okay, if I do the next one, and I'm actually going to just show you guys my notes that I already wrote, just because my technology is not working. You guys are used to that. Okay, so I'm just going to like this instead. Again, these are called geometric sequences. So when you think of a geometric sequence, you should be thinking of multiplication. Okay? So for A, again, you multiply each one by the next one, right here. Okay, so is this a geometric sequence? Yes, because I can multiply each time. So r equals 10. Now, if you look at the next one, now again, you have to go all the way through the sequence because it might look like, so this does have a pattern, if you notice. But what I also notice is I have to add, right? So if I were to add each one, we'll talk about what type of sequence that is tomorrow, but if I'm adding, that's different. So since I cannot multiply, that one is not a geometric sequence. Moving on to C. Anytime you have a sequence that is rotating between a positive and negative number, that is going to be multiplication, okay? If you multiply, you can go ahead and try it, but if you multiply by a negative number, obviously, if you think about it, so positive times a negative is a negative. A negative times a negative is a positive. A positive times a negative is a negative. So if you keep going, it's actually going to rotate between positive and negatives. So you know that your common ratio, or your r value, has to be a -1. Okay? So if you look at this, the number isn't changing. Basically, this is just opposites. So this is going to be a -1 common ratio, and yes, it does work. Okay, and then D is the last one. For that one, now the other thing to remember is your common ratio is always going to be by multiplying. It's always going to be multiplication. So, although this is going down, that just means that you're going to be multiplying by a fraction. If you think back to when we started exponential functions, and that's why we do geometric sequences and other sequences during this chapter is because that happened when we talked about y equals ab to the x power. If b is less than 1, which would be a fraction, if b is less than 1, then we can say that it is a decay, which means that it's going down. Okay? In addition to that, not only are the numbers getting smaller, but it's also rotating from positive to negative. So I know that my r value is going to be less than 1, and I also know that it's going to be negative. Okay, so A is just an example of how you would see it on the Regent. Okay, this would be a 2-point multiple choice question. They just give you a sequence of numbers, and you have to figure out what the common ratio is. Again, this word right here, you need to know what that is, okay? All they're asking you is to basically figure out the pattern. What are they doing each time, okay? So again, you need to recognize that geometric sequence refers to multiplication, okay? That's a multiplication. Remember, we don't use it times. I know I did it right here, but that's just, a dot would look weird in front of it. Okay, and then B, we have another one just like that. Again, they try to trick you with these. If you wanted to, and I'll show you this, but if you wanted to, you could put this into your calculator. Okay, again, I'm trying to figure out how much I would have to multiply by. So what you could just do is, let me see the numbers. Okay, so I'm going to do 3/4. Okay, and I'm actually going to divide it by -1/2. Okay, and I get -1.5. So then I can try it for the next one. -9. Again, remember, you have to use the negative sign, not the minus sign, when you're doing, when you're typing these in. Okay, divided by 3/4. I also get -1.5. Okay, so again, I'm just going backwards to do division, but it is a multiplication. All right. So then they gave you all of your answers as fractions. Well, if you remember, okay, so, okay, I got -1.5. If you can't think of that in your head, what that would be as a fraction, you could hit your math button right here. Okay, hit your math button, go to frac, and it will give you -3/2. Okay? That is definitely a nice tool. I know a lot of you hate fractions. Okay, next little set. Okay. And don't hesitate to ask questions. I know usually I do these so you can see how I started and where I went, but I will go through these one at a time, and then feel free to stop the video and ask questions. Again, my technology is not working, and rather than start over, I'm just going to work with it. Okay, so first of all, we have our explicit formula. So basically the reason for this would be, let's say I gave you a list of numbers. If you guys found the pattern, I know that you could tell me. So if I give you 2, 4, 6, 8, you'd be able to tell me the next number is 10. Well, what if I give you that sequence and I want to know, all right, well, what would the 100th term be? Do you want to go through all 100 numbers to figure it out? Absolutely not. So what we have is a handy-dandy formula right here. This does not need to be memorized. It is given to you. I will give it to you on the test. It will be given to you on the Regent. Okay? Again, I'm not going to ask you to memorize anything for our class that you wouldn't have to memorize at the end of the year. I'm not trying to make it any harder for you. I want you to be able to use your resources. Okay? So, we have a couple examples. So, what they give us, so for this, and I'll explain this really quick. So, this formula, these are subscript numbers. That means that they don't have any value, they're placeholders. So, a sub n represents a term in a sequence. A sub 1 is the first term. multiplication, common ratio, and then basically all this means n minus 1 just refers to, okay, if I am finding the 8th term, I need to know what the 7th term is first, okay? I don't need to actually know what it is, I just need to be able to write it down in my equation so that I can use it, okay? So again, all I need is my a sub 1 and my r values. So I look at my equation, or my sequence, I see, okay, it's going up by 3 each time, all right? So then I write down my a sub 1 and my r value. Next, I'm just going to substitute it in to the formula that is already given to me, okay? Don't forget your multiplication symbol, and put your common ratio in parentheses. Your common ratio is what is being raised to the power. So right here I have 7 minus 1. I'm sorry, 8 minus 1. This is an 8. Hard to see. So all I did was I substituted n, because I'm finding the 8th term. Okay, I'm finding the 8th term. So this, again, this is just what I write as a placeholder. Right? So then once I get down to here, this I can just throw into my calculator. Okay? And if you were to keep multiplying to the next thing, you'd be able to find this. But some of you might be saying, well, why can't I just do that in the beginning? Like 8 terms, 10 terms, 9 terms, that's not really that many. I can do that on my paper. Okay, but what if they give you the 32nd term? Also, they ask for the explicit formula. So you need to be able to substitute into this formula. Again, I will give this to you. I will give this to you. You do not have to memorize it, but you need to understand how to use it. Okay? So again, here are some examples. You find your a sub 1, you find your r, substitute, and then whatever the term is, that is your n value. Okay? So again, n equals 8, n equals 10, n equals 9. So you need to find that term, you need to find the equation, and then you need to substitute it in. Okay. So I'm going to give you these 2 more examples, and then I'm going to have you do the rest by yourself. Okay. So again, all you're doing is you're substituting in. Okay. So r equals -2, I find that based on the sequence. A is 1, you literally just take it from the first term. N is 15 because they told me. Substitute in to your equation that is given, and then check it in your calculator. All done. Okay, again, these are all pulled right from Regents, so they have given you these. Okay? And then B, same thing. Okay? So we need the 7th term. Sorry, I'm starting to get sick. I sound awful. Okay, r equals -5, and then a1 equals 2. Substitute them in as they are. Notice I didn't put a dot here. Don't need it. It's just a multiplication symbol. Okay, I plug this in. I know 7 minus 1 is 6, so I raise this to the 6th power, multiply by 2. So the 7th term is 31,250. Okay, so the rest of that page is for you to do. Okay, so I just wanted to, sorry, I don't want to show you the parts that you have to do on your own. Okay, and then the last thing I just wanted to show you is if you were given all this information, which of these you would choose. Okay, so since it says the word twice, I know that that's going to be multiplied by 2. Okay, so r equals 2, and then a sub 1 is 10. So just by being given those examples, or those choices, so I know that has to be geometric. Alright, so these cannot be an answer, so you can cross those right off. Okay, A sub 1 can't be the answer because, choice 1 can't be the answer because you need the n minus 1 in the exponent. So 2 has to be your choice. Also, if you notice, when this printed, it said an, like A-N. If you could try to make that look like a subscript, I apologize for that. I didn't notice that before I printed them all out. And then the last one, I want to know which function models the relationship. So if you can just go like this and figure it out that way, by all means, go for it. But the problem with that is it's not actually the answer because none of these have an x minus 1. So none of those are going to be the answer. So what I said is put these into your calculator and you will see. So if I go to my y equals and I type in 200 times 1/2 raised to the x power, okay, so if I put that into my calculator, that's the final answer, but you guys could go through all the choices. If I do go to the table, I see that that one is it. Okay. There we go. Okay. So 1 is 100, 2 is 50. Okay, so that one matches. So again, you guys need to get good at answering multiple choice questions based on using your calculator. Okay, it's just a lot easier. All right, so again, your homework is the rest of that, just those 4 questions that I left on this page. And again, if you have any questions, please let me know.